So, thank you for the introduction, Stephen. Like it said, this slide, my name is Jurgen Rurainsky. I'm working for the HHI, and especially for the image processing department, where I'm charged for marketing and also doing research beside. Because we have the main topic today, or one of the main topics is visualization, I would like to take the chance to put the words of our CEO in pictures that their visualization part takes place. So Fraunhofer, like you have heard, is located in Germany, and but not only there, because we have around the world offices which are present ourselves in the terms of technology, but also looking for new projects, industry partners. So I'm pretty sure one of these is really close by. Mr. Grad already mentioned that the Heinrich-Hertz-Institute is located in Berlin, really close to the Technical University, actually on the ground on the university in Berlin. And our main topics are the communication networks, photonic components and sensor technologies, 3D visualization, content creation, image processing, and also video coding. And with this part, we were able to achieve last year 2 times the Emmy Award for H.264. The HHI itself covers the whole value chain from data collection, data coding, networking through different kinds of channels, transcoding, changing the data, making it more usable, and then also displaying it in different types of display, different types of projection system. And one major goal for the last couple of years also is the immersive part, which comes more and more the biggest issue in the terms of data visualization. But let's start with the topic I'm here for. I will talk about 3D, and to give you the first impression about is something like this. You may know this, you may not. But in the meantime of 1915, they have come and go several times 3D peaks. So there was joining people were in the cinema watching 3D movies, and then sometimes the whole idea broke down and nobody was more interested. Right now we see a new approach with the movie Avatar, which started the whole area, and then something like this happened like last year, where we captured only 3D, a pop concert, and then transmitted this pop concert to 91 cinemas in Germany, not only in Germany, but also to other 5 countries in Europe. So this gives you an idea that a completely new type of entertainment is taking place right now. So, and this all comes with also a new type of visualization in the 3D sense, in the immersive sense, to be more a part, even if you are not there. So I put here, I took some drawings here from Pricewaterhouse to show you what their expectation is right now in the terms of 3D screens and movies. So all of them are growing. There is no question more about that maybe they're breaking down and this 3D thing will collapse somewhere. But if you're talking to the community, the major concern of all of them is what happens if you have bad stereo. And I can tell you that maybe 50% of the current movies which are coming out today are bad stereo. I don't want to tell that the content is bad, but the quality of the stereo is bad in the terms of how the images are aligned, how is the geometry, how are the colors, and so on and so on. So this is a really big concern. And right now, companies like RealD, you know this from the cinema, starting looking what can we do to get rid of this bad stereo. So here's something which gives you an idea where we are right now in the terms of spreading around the 3D data. You see 3D Blu-rays, you may have one at home. There are not so many of them, I know. But here in the US, you have already sport channels transmitting 24/7 3D sports games. There are a number of different activities in Europe and in the US as well, forcing or putting together new technologies, new ideas for creating less expensive, better 3D content. And this year you will see that even companies like RealD going in also in the area of 3D production. So they have captured last year an opera in 3D in London. So this will also be shown in the cinema. So you see there also is a new type of entertainment out there. So some specs about 3D viewing, if you're talking more for the living room. So glasses, if you're talking to people, nobody wants glasses in the living room. They're not acceptable for there. So there are many different display technologies. One of them, or most of them, have the benefits, and most of them have also the drawbacks. Not all users can really see stereo, so maybe roughly around 10%. So there should be an option to turn off 3D. And one really nice saying of the head of the department is the best 3D display is this one where you can turn off 3D. So even if we are pushing the idea with our research and our technology in the terms of 3D, we're also focusing what happens to the people who don't want to see 3D or not want to see all the time 3D. Like I mentioned before, we're covering the whole value chain. I will not cover today the 3D capturing part, but focusing more on the coding, the transmission, and then on the displaying side. So you know there's these 2D displays, they're stereo-based, you need glasses, and there is this big thing coming up, out-stereoscopic displays. With 2 views or more for the living room than with 2+N views. So looking now for the coding part, I just have to mention, if you go in today and buy a 3D Blu-ray, you will find the movie which is encoded there with MVC, which is partially developed also by the HHI. What it's doing is not they're increasing the bandwidth. It's not saying, okay, I have here the left view and I'm just adding completely the bandwidth for the right view. So they're looking really for how we can gain benefit from the 2 views. They're almost looking to the same thing. And if you see now here, this chart shows you what happens if you would add more and more views. So let's take the idea of this Blu-ray and just extend this idea to out-stereoscopic display, what I have mentioned before. It means you have a linear increase of the bandwidth which is required. I'm aware of this, that each year the bandwidth for the home user is increasing, but not this fast as you would like to have for out-stereoscopic displays. So there should be another way how to get the data from the server or from the broadcast channel to the home user. And we think one solution is MVD. And here's a short explanation what MVD is. It consists of the left and right view as it is today, plus a left and right depth map. So, and these 4 input data can be used to render the views which are required for out-stereoscopic displays on site, so at the consumer side. And this can be done really easily. This is not this big effort anymore. So, but how are we producing these depth maps and how we transmit actually these data to it? So creating these depth maps, there are now research is going on for 15, 20 years already. And we're also showing outside an exhibit which shows you some results of these determination of the depth maps. Transmitting these data, there was already a test in Europe to use this kind of data and see how this can perform under real everyday environments. So transmitting both views plus 2 depth maps, and this wasn't success, but again, it's just a test. So the future will see how the broadcast channel or the channels can be incorporate this data in their transmitting chain. Another approach, you see right now here in the US, the LTE 4G network is increasing. Another usage for this, than not just downloading movies or browsing faster, is to use it for broadcasting TV, and not even 2D, even 3D. And with the technology of LTE, you're even able to allow products or products, you can say this are for 3D, that you can ensure there are premium users which pay for the 3D content. We can assure that they always have 3D content, and the 2D users maybe only get 3D if the perception is good. So there is some value there for the company who are going to provide, the wireless company like Verizon, for putting 3D data, live transmissions on smartphones. So, like I said, the 3D auto-stereoscopic display will be in the future there. What are the steps until we can reach this goal? Of course, we have to finalize the standardization of this MVD, which is not done so far. And we have to get rid of these resolution issue, because if you have an 8-view display or a 9-view display, you're losing resolution for each view. Or if you have looked to the SID, which was taking place last week in Los Angeles, there's a new idea by increasing spatial resolution, by interpolating over the time, so new data to it. So there is something going on. But we think that 3D TV on a mass market, that you're going, buying it, putting it home, plugging the HDMI cable in, and see 3D maybe taking place 2015, something like this. What happens in the meantime? There has to be something, because otherwise we lose the people who are interested in 3D. New type of cooperation taking place. Really, and Samsung has shown last week a new display, full HD resolution with not shutter glasses, with passive glasses. So new cooperation starting up. Or you can give the user more control of the 3D content. Like you're changing the color of the current display or of the current viewing, or the volume. You also can change the 3D perception. Let's say you want to change how much outscreening you have. So how much object actually you want coming out of the screen. Take your remote control and adjust this. And by the way, these menu items, unfortunately all in German, is an outcome of a German project with Löwe, the last premium TV manufacturer in Germany. And they have shown this is possible. You can really do it. And also the depth budget. So how much depth actually I want. And this depth budget is also a big issue regarding the auto-stereoscopic displays, because not all of them have the same specification. You have to find a way to adjust this. Here again, something what I taught in the beginning about bad stereo, automatic correction of the geometry and also of the color. And don't believe this happened only a spare time, or a few times out of 100. This happens maybe 85% of all 3D data which is out now. So you have to do something to correct this image so that the people have a nice view and don't get a headache and so on and so on. Here's an idea of in which parts we are taking place or putting our research in. Some European projects, all of them related to 3D, starting from mobile communication, from handheld devices, up to auto-stereoscopic displays, multi-projections, satellite communications, teleconference systems in 3D. So I'm almost at the end of my slide. I'm maybe a little bit ahead, but it's not a problem. So if you have a chance to see how auto-stereoscopic displays can perform today, there's a chance outside, and my colleague Ulrich and I will be staying there, and we are welcome to show you what we can do or how this display can perform today. So thank you very much for your attention.
And we have time for questions. Questions for Jurgen. Okay, age, sign of age. Ah, we have one, yes.
No one else does, I do. How fast are the production costs coming down? And how fast is the margin of 3D movies coming down over 2D movies? And also, if my production costs are very high, and they stay quite high, and the margin of 3D, or the add-on that I can sell it to the end consumer is not coming down, and I don't have a turnover, and everyone at some point has 3D televisions, I lose money.
Okay, I'm not a 3D producer, so I cannot really tell you what a production cost is, but I can tell you from the research side that we see there is a potential for, let's say, helping tools on set, which help you to reduce the costs and not going forward and back between shooting site and post-production. But how this can be put in numbers, I don't know. I'm sorry. But of course, like I said before, all the companies related to 3D from the consumer side, transmission, from the cinema people, all of them have recognized this issue, reducing the production costs of 3D, and there's a lot going on in the moment to reduce this.
Thank you. And one last question here.
Can you explain why you need left-right depth perception? Because it seems like to first order, if you move left to right, the depth doesn't change. And so is there some obvious reason why you need left-right depth and not just one depth?
I can tell you that maybe you're familiar with the Philips format LDV layer depth video. They have announced and say, well, why not using just one view and one depth, which should be completely enough. Maybe an occlusion layer to get rid of the things if you maybe look around a little bit. But we have proven that using left and right view plus two depths is increasing the quality of the outcoming rendered virtual views really dramatically. Maybe Philips is looking this from a different side, but we can show it on numbers. That it's proven if you going with each view to have an independent depth map, you're increasing the quality of the final virtual views.
Jurgen, thank you very much.
No,
We're
okay.
Okay. Yeah. Again, we'll